Hi, I'm Archit, and today I'll be talking about my project What a Pose. So in this project, I have built a 2D pose estimation model. And what this model does is this model predicts the location of joints and body parts in the image and classifies the yoga poses. So my data set is a two-dimensional color image that I got from Kaggle. It's a free open source data set. And I'll be feeding in this data into my machine learning model, and the model is going to perform the post detection, and it's also going to tell what image is what kind of yoga that person is doing in that image. So I have in this project, I have built a couple of machine learning models. The simplest one was the logistic regression model, and then the second one was the convolutional neural network that I trained from scratch. The third one was the convolutional neural network that I used with VGG16 transfer learning. And then the last one, the best one, was MoveNet model that was originally built by TensorFlow. So I'll walk you through the entire code and the data set. Talking briefly about the first one, the logistic regression model. So logistic regression model is actually meant for binary classification, and it's not actually meant for image classification problem. But I just wanted to see how a simple bare bone model can do in the image classification. So I deployed this model. And before deploying this model, I had to actually convert my images into a NumPy array, and then I had to do some feature scaling, and then I had to reduce the dimensionality using VCA technique. So on the right, you can see the confusion matrix. It has many misclassification, and the problem with this model is also, as expected, it's going to have low accuracy because it's not originally built for image classification problem. And since images have high dimensions, logistic regressions is more likely to do a poor job on it. Now, moving on to convolutional neural network. So initially, I started building a convolutional neural network from scratch. Initially, I did not use any transfer learning weights. And the problem was that it was overfitting. It had low validation accuracy, and it took quite a while to train it. Even though if I'm using a NVIDIA GPU, it took quite a while to train that. And in order to address the overfitting and many other issues, I added dropouts, and still it wasn't a significant improvement. So I moved to convolutional neural network with VG16 transfer learning weights. And the thing about this was that it gave me a significant higher accuracy. It was less overfitting and it was fast in training. And I'll actually show you all the plots in my code walkthrough. And also the plots and everything is and the working mechanism is also being discussed in my report in details. And the last one was the MoveNet model, which gave me the best model accuracy, and it was pretty fast in training. I had to download the pre-trained weights from TensorFlow's official website, which I have also discussed in my report. So here we can see that on the left side, we have the original input image. And on the right side, we have a bounding box that's detecting the pose. And we can see inside it's detecting the joints and the body parts of the person doing the yoga. So again, this one it's called goddess yoga pose. This one is called warrior yoga pose. This one is called downward dog, and this one is called tree yoga pose. So here we can see on the right side, the model output has marked the joints and the body parts in all different yoga poses. Now I will walk you through my data set, and then we will go through the code. So as you can see, this is a Kaggle website. It's a yoga poses dataset. It has two splits. It has train dataset. It has a train directory where we have images already categorized into different types of yoga poses. So here we can see if you click on the downward dog, it's going to show me all the images in which the person is performing downward dog yoga pose. And then if I go to the plank, it's going to show me the images of people performing planks. And similarly, it has a test directory in which there are same categories, but just less number of images. So I simply downloaded this data set, and I am feeding in this data set in the same directory structure to my code. So now it's time to go through the code. Here's my Jupyter notebook, and I have the comparison of all three models in the same notebook. So here, let's begin with the first model, logistic regression. Here I'm importing all the necessary libraries, and I'll be using my NVIDIA's GPU. So this import is necessary for that. And these are the pre-processing required. So first of all, I need to load in the data, and then I'm converting the data into NumPy arrays, and then I'm storing it on local disk. And then it's going to read in that NumPy arrays in images. It's going to load that. It's going to split the training data. So initially it's going to read, it's going to convert both the training directory as well as the test directory, and it's going to create a NumPy array file. So here we can see the training data set. It has this train folder and the test folder. It's going to read it in the same structure. Then it's going to split the training data into the training data and then the validation data. And then I'm performing the scalar, standard scalar, so I'm scaling the data. And then I'm doing principal component analysis. I'm just keeping the 95, the top 95 features. And then I'm passing in that reduced data to the logistic regression model. And here I am getting all the accuracy and the validation and the test accuracy results. So here we can see that the validation set accuracy was about 64%, and the confusion matrix. So this is the same matrix that I showed in the slide. Then I am training a convolutional neural network from scratch. So for that, I'm using this function. It's built such that it's going to again do the same. It's going to read the input files from this dataset directory, and it has to be in the same structure because it's the labels that are given to the directories. Those are actually telling the code the pose that this images belong to. So this is going to read the input images, and here I have the model built up. So these are the layers, and then I'm compiling the model. Then I'm using again the GPU. So if you don't have a GPU, we'll have to comment this code. And I'm training it for 10 epoch. And here you can see I'm running the validation set now. And I'm getting an accuracy of about 17% on the validation set. Then I'm saving the model. Here we have confusion matrix. And different type of different type of scoring functions are also shown in the output here. Then I'm adding dropouts and retraining it, and here I'm seeing slight improvement. And again, this is the confusion matrix. Then I'm using convolutional neural network with transfer learning. So here, yeah, it's reading the same structure, and but the only difference is that now I'm using the pre-trained weights from VGG16, and it's going to again recompile it, I'm training it, retraining it with some added layers. Here I have added 2 more layers to it. It's going to recompile, it's going to retrain. And here we can see the validation and the training accuracies. So in this downfall, and then it goes up, and then here it again comes down. So we can say that probably training it for 7 epoch, 7 to 8 epoch is enough. Then training it a little more is going to show us a difference in the validation and test accuracy. So that's probably the sign that it's overfitting a little bit. Then I am training it on, then I am testing it on the test data. So here we can see the confusion matrix. And then my final model is MoveNet model. So in the MoveNet model, I used some of the libraries that are already provided by the TensorFlow in their documentation and tutorials. So it is important to have this .py files in the same directory as the Jupyter Notebook, because this Jupyter Notebook is going to call the functions that are in this files. So here I'm importing utilities, data, and MoveNet that's in this .py files. And then it's going to detect, I mean, that these functions are to draw the the joints and the body parts in the output image. So here I am testing it on one of my test image. Here you can see that it marked the joints, and then it drew a bounding box around. And the final one, I'm testing it. I'm training it, and then I'm testing it in on the test data. So here we can see the training and the validation accuracies. You can see they both are going up, and there isn't a significant difference, which means that it's not overfitting as much compared to what we saw in the convolutional neural networks, and also what we saw in the logistic regression. So here we can see that the training accuracy have significantly improved, also the validation accuracy, and I'm saving this model as MoveNet underscore model. So in order to use this MoveNet, it is important to have the pre-trained weights downloaded from the TensorFlow website. Here it's called MoveNet underscore thunder.tf lite file. This file is needed if you wanted to retrain using the MoveNet model, the MoveNet model code that I have given. So what this MoveNet model is going to do is it's going to create another directory that's called poses images out in the same directory of the test and the train. So here it's going to create the directory, and it's going to show the outputs of every image of every input image it has taken. So as you can see, that it drew uh, the joints, and it marked out the body parts, and it also made a bounding box. And this is going to be the output for every single yoga pose image that we have provided it. As you can see, it made it for all different poses that we fed in. And it did it for both training and the test data. This was the test data directory. Now I'm going to go to the training data. These are the original input images. So it's going to refer to the same directory. Then going to show us the output of the input images in the out directory. So in this project, what I concluded was that the logistic regression, it was giving really poor results for the image classification, and then convolutional neural networks without transfer learning, it was overfitting a lot, and it was too slow, wasn't giving a good validation accuracy. And the convolutional neural network with transfer learning using the VGG16 weights, It was giving slight improvement, but still the best one was the one that's called MoveNet. It's specifically meant for detecting the human body poses in images and videos. And this project can be taken up to next level by adding real-time image processing capability so that we can clean video stream and we can perform real-time post detection on it. Thank you so much for this.